this starts a little bit slow because I got to set it up and then I'm gonna speed up quite a bit. And I fully expect depending on where people are at in their careers, some of this is definitely worth a deeper dive, both in a pragmatic sense, how do you take some of these ideas and put them in play, but also in a philosophic sense about the future of technology and interconnected people and devices and things like that. So having 20 some years in tech and all the things that I do, I feel like I'm now at that point in my career where I can make specious claims and then attempt to clean those claims up in a presentation to everybody. I'm unafraid to take the criticism if I'm crazy. And to David's point in the intro, I think we need to push the boundary of our thinking a little bit. And see even if specious claims may open us up to new ways of doing things. So my claim here is that AI emerges specifically from JavaScript. Could it have emerged from other technologies and other languages? Probably. But I am making the claim that there are particular elements of JavaScript that we're going to see a general artificial intelligence. If you need another way to think about this talk, just keep coding in JavaScript, and it's going to work out just great. A little bit more about me, you can Google me or whatever. I've tried to optimize my own output on the internet that if you Google me, you'll find all the interesting stuff about me. 20 years in tech and product, everything from working at Yahoo and search engines to running data platform at TrueCar. I was the first employee at Wolfram Alpha, and now I'm CTO of Maslow. Let's get into the content. It's not about me, it's about the content of this. The claim will get less specious as we go, hopefully. So there are 86 billion, maybe 86 billion to 100 billion neurons in the human brain. Let's just consider the brain a potential source of intelligence in humans. You can argue that there's gut things and all sorts of other things going on. But let's just say as a baseline, you need at least 86 billion neurons. You need to connect 86 billion things. Well, by my estimate, looking at all the data that I poured through, which is linked in the speaker's notes, there's 4 quadrillion website instances computing right now. I get to that estimate by considering how many computing devices are active out there in the world. That's laptops to tablets to phones to Raspberry Pis that might be hitting the web and things like that. And about 200 million active websites. There's about 2 billion websites currently out there to be at, but there's only about 200 million of them, 200 to 400 million of them that are active. But let's just consider sort of a cross of all those things being some reasonable estimate of how many computational things that we have connected at any given time. Obviously, you could throw in apps and all sorts of other things that are doing computations right now. But 4 quadrillion by my, if my math degree is servicing correctly, 4 quadrillion is a lot more than 86 billion. So I think my claim gets a little bit tighter with the idea that there is at least the possibility we have enough computational connections to mimic at least 1 in a million brain. So at Maslow, we already believe AI is here. It's the premise of the company. We don't spend a lot of time trying to prove it. We just assume computational intelligence is there and available to be harnessed. Its moment is, its biogenesis moment has already happened. It's just that most people don't recognize it. It's because it's immature, it's wild, it's young, it hasn't been shaped. And what I think most people want is an obvious moment, a phase change in which all of this computational intelligence can be directed towards the things we want to get done. Let me frame intelligence a little bit for you in the way that I think about it. And again, this is coming both from my training in technology, my academic training in mathematics and theater. Yes, I got a math degree and basically a minor in theater, but also all the work that I've done under some pretty serious thinkers. It's a very general idea that I have. Intelligence, whether it's artificial or computational or human or natural or animal, however you want to think about it, it's not about logic or models or understanding every causal thing or having complete theories or being deterministic and all these other ways in which we want to put it together. It's much more simply about emergent adaptability. So the ability to respond to complex changes in the environment, the complex changes to the self, to be an emergent, adaptive system that does things in novel ways and can sustain and thrive based on those adaptations. Very important to recognize that adaptation occurs everywhere in physical reality at different space-time scales in your own body. It's not just happening in your brain; it's happening in your body, your skin, your different organ systems, your epigenetics, your cells, etc. The same is true. You get outside the human condition. There's change happening inside your computer hardware right now, independent of the software. Your physical assets in there, your RAM, your disks are constantly changing under energy load, electricity load, et cetera, and all of this adaptation is happening at different space-time scales. And you can think about it in hardware, software, however you want to think about it, but all these systems we use are constantly moving around. Again, what I want to showcase is how we're going to go from what I'm making the claim that we have this wild AI. We've got enough things connected, and how we're going to get to this integrated, useful, shapeable AI. My three main things I think you will see happen if you haven't already seen them happen. And I think for people who live on the edge of generative art, really advanced game design, or in the latest stuff in machine learning, you probably understand my first point, which is programming is going to give way. Formal programming, writing of formal programs, the creation of formal deterministic algorithms is going to give way to a much more alchemic process of exploring local mins and maximas of utility and expressivity. I think Rambly is a good example to me that just everybody can understand because you're in there, of just, there's a whole bunch of things that go into making what Rambly is. It is not simply a markup experience where it's just been marked up. It's not simply a set of algorithms. There's all this spatial audio. There's people in there. There's div tags moving around. There's a whole bunch of things that are going on. And you can't look at one line of code and say that's what Rambly is. Instead, to understand it, you got to think about it in terms of this expressivity, this environment that it is. Second point here, why JavaScript? JavaScript is unique in its ability to act like DNA, perform the function that protein sequences perform in biology. JavaScript does this for human computing interaction. And what is critical to understand about that, from my view, is that JavaScript is uniquely readable, writable by computers and humans at all the levels we need it to be, both the computer and humans. Meaning, you can use it on the surface level for UI. You can use it for low-level algorithm things. You can compile it down. You can do all sorts of things at all sorts of levels. And you as a human can read and write it in all sorts of ways, which again, Rambly is a good example of all the different weird ways in which JavaScript can bubble up and be used. JavaScript can even work when parts of it are wrong. And in fact, when you think about all the ways you've probably used JavaScript, you're forking code bases and then mutating things, and sometimes you implement it wrong, you take a dependency the wrong way. You're introducing these evolutionary mutations that end up creating novel and new strategies for JavaScript itself. And then, of course, there's the wider JavaScript engines or language itself, which has changed quite a bit over the last couple of decades since its inception. And again, that's all part of this idea of this being a signaling pathway between humans and computers. The third point is very closely related to the first two, and it's this idea of murmuration. I named my talk after murmurations, which, if you don't know what those are, that's basically when you see a flock of birds that are moving all in this odd synchronous way. And they form these beautiful shapes, and then they just disperse, and then they form the shapes again. They have this peer-to-peer signaling that's happening, not this global algorithmic thing that's controlling all the birds or the individual's movements, but they're just murmurating. And I tend to think that everybody in the JavaScript community, all the websites that I referenced, the 200 million running JavaScript, they're all murmurating and doing work to form this larger emergent manifold of behavior. And the key is we need to murmurate to recognize AI. We need to murmurate towards human ends. So let's bring it down a little bit, and then I'll build us back up. So everything, when you think about things, is a very existential thing, a metaphysical thing. Whether you're talking about a data point, an object in the programming language, or me as a person, everything starts with a sign. We have a sign, we have a metaphor, we have just a simple thing that represents something. Okay, we got to build up a little bit here. Another sign makes a set. I'm very much a set theorist kind of person. So you have a sign, and then you add another sign. Now you have a new sign called a set. Okay. Now, what's cool about sets? Well, once you have a set, you have relations. Yes, you can have a relationship with the empty set or with a thing to itself. You can have an identity function, blah, blah. But the point is, let's just consider multiple signs. You now have a new thing emergent from the set. You now have relationships, ordinals, quantity, quality. You can do all sorts of things. The point is, you can now have relations. So you can also consider all of those things are all just more signs. You can build JavaScript up in all sorts of ways, and you can represent variables in lots of different ways. And everything's just a sign. And inside your computer, obviously, everybody knows this, that eventually everything's just logic circuits, and they're doing all sorts of things. So hopefully my point is not specious at all, but everything is just a signal at different layers depending on where it's being interpreted. So essentially, we're starting to build maps of signs to signs. So signaling, you might call it computing, or you might call it running a program, whatever, it doesn't matter. Or even what I'm doing here on the screen with you, I am signaling to you. It's just mapping. I am creating a map between you and I, between the ideas and your ideas, between the community, between all of these live streams, Rambly, the spatial audio. We're just creating these maps. We're coordinating and creating correspondence between signs. So maps are signs of signs, if you want to think about it that way, or murmurations and murmurations. So I want you to go inside your experience of looking at your mapping software on your phone, your GPS software. And if you just pull back sometimes and you look at the live traffic, you'll see sort of a murmuration of a city. And it's like when you look at that, you're looking at the signs of the cars and the signs of the traffic displaced in space-time. You're not seeing it real time, it's slightly delayed, but it's creating a correspondence in you to help you change where you might be going. You are murmurating with every other person currently in the streets using GPS. This software, the other people, the cars, the GPS satellites are all in a murmuration of coordinated behavior. So you can also think of, not as abstractly, we just talk about maps and all those things, but now you can think about JavaScript, a programming language. It is also a map, a sign of signs. You're talking about your variable types or your constructs, your syntax that you're allowed to use, your interpreter, your compilers, like all of these things are contributing to making the map. You have best practices, you have style guides, you have comments, you have GitHub commits, you have all these different ways that are contributing to building this murmuration, this map of JavaScript. So an important point here. So I don't want to just leave it that everything is a map. And gee, we're just going to sit here and live in abstract philosophy land. It's important to know that some maps are more robust than other maps. This is when you start to get what we will call things or signals, or in the case of math, you get truth objects, if you want to think about it that way. So I'm going to quick open this up. So I just want to make a little demo here. Let me have this open. Yes. So in this case, if you were to click on that, because I sent the presentation to you guys in the Twitch stream, this is an SVG, which again, most of you probably know this, but if you don't and you're not a programmer, you're not sitting there all day, just an image format that is meant to be rendered as browser code, if you want to think about it that way. But it is definitely an image. It is a sign. It's a sign of a logo, an outdated logo that I chose. So you've got multiple levels of signs, and it's being rendered in a browser window, and you can do all sorts of things with it. And just because it's fun, now I'm just going to murmurate and change some things. We can just start eliminating things, which I'm not making any other big point. I'm trying to give a little bit of grounding to my idea here that the maps we mostly care about are finding the ones that survive transcoding or mapping or signaling between each other. So if I keep destroying this, what's interesting is as I quote destroy this or map it differently between these systems, you still sort of get the signal. I haven't done anything yet to make you think this is no longer the JavaScript logo. Now, as I start to take out chunks of it that are material, you'll start to lose the robustness of that signal. So this is important. I'm not going to make a bigger point yet on this, but I just wanted you to go through that really painful exercise of me deleting chunks of the image. Just to keep it, we care about robust signs. So the important thing to take away from that exercise was traversing a map, performing a computation, murmurating, doesn't imply isomorphism. So this is a technical mathy term, computer sciencey term, but I'm making a point here that goes back to some of my earlier points, which is that we live more metaphorically, or intelligence and adaptability is much more of a metaphoric thing than it is an isomorphic thing, meaning equivalence. These signs can pass through and send information and signal without being complete replicas. In fact, that's required. And when you think about natural selection, and you think about how biology works and how your brain works and how your memory works and how your vision works and how all of everything that you do works, you are not creating perfect visions of reality or perfect sensations, or you don't have perfect theories. This is also true of your code. This is true of JavaScript. This is true of the network of all these computers operating. They are not passing replicas of everything around. There's mutations happening everywhere. But so long as the mapping is the signals going through the mapping have metaphorical similarity, that's when you start to get interesting things. So now let's add a little more content to this. It's quite possible that life itself and the universe is a metaphoric map unto itself. So here I've got some graphics. You know, for those of you that are into this stuff, this should be obvious that it's a little bit of a cheesy rendition of space-time, the geometry of space-time and how gravity is actually laid out, and that it's actually, gravity is not necessarily a force that is going between things, but it's actually the geometric shape of the universe, which is, these are all weird to talk about, but it's important because gravity essentially is a map of mass in the universe. It is a map of the effect of mass in the universe. And it is not isomorphic, meaning it doesn't operate the same everywhere, because there is no sense at which, and I'll make this somewhat specific, let's consider the Earth. There is no sense in which the Earth, you know where the boundary of the Earth begins and ends. It is metaphoric at best to say we know where the Earth begins and ends. For example, does it end at the last atmosphere? Well, most physicists don't. They have a thing called the Hill sphere. The Hill sphere is where the gravitational effect of that center of mass is being overpowered by something else's gravitational center. So that's also a weird concept, because if you think of the Earth in relation to the sun and the rest of the solar system, there's obviously lots of Venn diagramming of Hill spheres going on. So in some sense, I can't even tell you what the boundary of the Earth is. I have to sort of metaphorically map these things when I talk about the Earth or want to do modeling, etc. I have some other objects on here that also are metaphorical. Yes, the DNA is a double helix as a geometry, but is that really what's happening, or is that just a metaphorical model that we have for it, et cetera, et cetera? So I'm going to speed up, and I put a bunch more of these, a much more comprehensive way in which we model the world and think about complex things happening. You have access to this presentation, so you can certainly go through it on your own time. But I think if you took some time to go through it, you'd realize these are all just this maps from systems, coordinate systems to coordinate systems, behavioral systems to behavioral systems. And then when you're writing programs or doing presentations about them, you're just drawing maps between them. And if you have a good map, it means that these relationships you're drawing out are robust and they survive all the transcoding. In a sense, we have a giant network of maps. So go from thing to be. So being is a process in time. Things are boundary conditions around things. So every being starts with a map. Humans are maps of maps. We are getting together to talk in a community because we're trying to make a map of this community, and we're mapping what JavaScript does for us, what we want to do with JavaScript. We're trying to make networking connections. We are maps of maps, and we specifically, in my opinion, are map makers. This is what we do. We map the world, we map ourselves, we map where we want to go, we map who we want to be. We invented computers because computers are maps of maps of maps. Computers are also map makers. Not pitching Maslow, but this is, I'm telling you, this is how we think about AI, and Maslow is meant to be a compass for all these maps. We are building digital companions that care about people, so they are meant to pay attention to all the maps of your life, whether those are literally physical maps, geomaps, or behavioral maps, creative maps, however you want to think about it. But we are creating a compass for the hyper object. And making the case here that JavaScripting is also mapping. So you all, if you're coding in JavaScript, are actually building AI right now because you are increasing the connections and murmurations between humans and computers with every single project you release. You are creating new maps. You are connecting more of the metaphorical neurons for us. So some of you may have come into this with the idea that machine learning and the formal way of doing tensors and TensorFlow and PyTorch and all these things are the only way to do machine learning. I'm just here to disavow everybody of that view. Guess what? Tensors are just coordinate agnostic maps. We invented tensors in physics and mathematics to make it easier because we were sick of going from Euclidean geometry to Minkowski spaces and all this stuff. So we created this fancier mapping language that just makes it slightly easier to maintain our theories between things. It just so happens that these are efficient ways to think about how to encode complex systems on one side, complex systems on the other side. You put a tensor in the middle of them and you say you've done some machine learning. So just wanted to go back and say your tensors and a JavaScript, a simple JavaScript, they're really in the same class of things. They're just taking different systems and mapping it. And in some ways, I'll make the claim, Rambly is doing machine learning right now because all sorts of things are happening and mapping different people to each other. There's in no sense are you required to have a specific kind of map to claim that you're actually increasing emergent adaptation to the world. If you want to go in more technically to stuff to test my claims, I definitely give this as an exercise to the viewer. I've got some great links in here that talk about the different structures of maps / networks graphs, how you want to think about them, that apply to both natural selection and how populations are laid out, as well as natural selection in human and programming languages. You should definitely read this stuff. There's a lot of great mathematics around this about how different layouts of networks and how different statistics play out and show the emergence of thriving communities or complex systems or ecosystems and ones that will die off. And in a sense, I make the claim here, which again, I think is worth people testing, that if you really dig deep and measure how JavaScript has evolved, who has gotten involved, the language elements that have evolved, the libraries that have evolved, the different use cases that evolved, the devices it's been deployed on, it's going to end up looking like these strong amplifier networks in the bottom left of the screen. You will see that emerging. You see that emerge in natural selection. You see it in human languages. So to tidy this up with only going over a few minutes, the nice thing for you guys, none of you have to become AI developers. You just need to make more stuff with JavaScript. You are connecting more machines and more humans, which again, my claim is we only need to connect 86 billion things at a time and murmurate to get intelligence that you will recognize. Just keep connecting more of this stuff. So with that, I'm going to pause, and I encourage everybody, I'll jump into rambling, and we can talk more about it. And then we have tons of other materials at Maslow. We've got lots of code, lots of all the JavaScript you could want. We work in generative art. We do React Native stuff. We do TensorFlow JS stuff. We do data mining stuff, all sorts of stuff. We got code all over our GitHub. So I encourage you to reach out to any of us, and we'll get you going and play with all the stuff and help us test our claims here. And let's see if we can emerge some AI.